Hi guys, Mrs. Delisin here. Welcome to another lesson of AP Statistics. Today's lesson is estimating a population mean day 2. We are going to formally learn how to do a confidence interval for sample means. How many states can you name in 1 minute? We will use this class as a random sample of all AP Stats students to estimate a 95% confidence interval for the mean number of states an AP students can name in 1 minute. When the timer starts, list as many states as you can on a piece of paper. Write the number of states you listed on the board. So what type of data, and we're going to do that in class, so I'm going to skip that at this point. What type of data is this? Is this a categorical or quantity? And because we are naming states, right? And we're gonna okay, this is categorical variable. But then remember, we're not naming the states. The data is not naming the states, but how many you can name, right? So this is quantitative. Okay, and for means, there you go. Enter the class data at Statplet.com and find the sample mean and standard deviation. Sketch a dot plot on the sample data. I am going to provide the data that I got here. We have n from last year. We have n equals 32, and then this is 1, and this is 5.527. Okay, we are going to construct a 95% confidence interval to estimate the mean number of states a senior can name. We're going to use the numbers that we have: n equals 32, sample mean of 16, and a standard deviation of 5.527. State the parameter you want to estimate and the confidence level. So of course, we want to estimate the true mean number of states an AP student or AP Stat student can name in 1 minute. Okay, a confidence level of 95%, it's given. We are going to name our procedure. This is one sample. Not going to be Z interval because we are talking about means this time. This is one sample, T interval for mean. Our check condition, we check it's a random sample. We are going to remember we are going to we're going to use the class to take a random sample of all AP Stat students. So yes, this is a random sample, checked. And then 10%, 32 is less than 1/10 of all AP students. And then we have, or AP Stats students. And then we have for normal, 32 is greater than 30. So CLT is met. We are going to have our general formula for any confidence interval. For any even sample proportion or sample means, they have the same general formula. Point estimate plus and minus margin of error. And then for the specific formula, we have X bar plus and minus T star S of X over N. And then plug in numbers into the formula. Our X bar, our sample mean, is right here on the top, 16.813. So 16.813 plus and minus for this T star, we are going to get the DF first. So let's use our table. Let's find, where do you put, let's put DF in here. So we have DF equals n minus 1. That is 32 minus 1, that is 30 at 95% confidence. So we are going to find our T star. So let's go to the table. 30 is right here. Oh, actually, sorry, let's go back. We have, I did 32 minus 1, right, is 31. But then, let me just do that again. I think I made too much shortcut. So 32 minus 1 is 31. But then, because in this graph, we don't have 31, we're actually using 30. A DF of 30, we're going to go down. And then a 95% confidence here. So our T star is 2.042. Okay? Again, it was supposed to be 31, but since there's no 31, I went down to 30. Alright, so my T star is going to be 2.042. 2.042 with my sample standard deviation 5427 over square root of 32. Okay, so that is 16,813. I am going to multiply this one first, and then I'm going to do plus and minus after. So this is, can you guys make sure, check it on your own calculator. So I will do 16.1813 plus 1.995. That is, again, verify with your calculator, 808. So interpret your interval in the context of the problem. We are always going to start with that. 95% confident that the interval from 14.818 to 18.808 captures the true mean number of states an AP student can name. An AP Stat student can name in 1 minute. Okay, there you go. So that's it. We have to name the procedure, we have to check the condition, and then we have to solve for the confidence interval. And then we are going to do our important idea section. I think there's not really anything a big deal for the steps right here. We just need to remember, obviously, our formula T star, which I also put it on the previous page, on the previous lesson I meant. And then don't forget DF is n minus 1. Our name of the procedure. Name of the procedure is 1 sample T interval for means, right? And then we're gonna check the conditions, same thing, random first and then 10% condition, and then make sure that you checked for normality. But now I'm gonna add something that is kind of different, right? So for normal, we always use CLT, right? And CLT means that n has to be greater than or equal to 30 for it to be approximately normal, right? So when the population is approximately normal, when the population is approximately normal, so the sampling distribution is also normal, correct? Okay, and then the second is if the population is not normal, or if it didn't say it was normal, we have to check our CLT that our n has to be greater than or equal to 30. Now, there is another one, which is number 3. If, let's say, for example, the n was not greater than or equal to 30, right? The n was not greater than or equal to 30. The n was like lower than 30. For as long as the sample shows no strong skew or outliers, we still can say that our distribution is approximately normal. Okay? So, what does that mean? Right? I will repeat that. So, in cases where n is not greater than or equal to 30, and then the graph or a dot plot or a stem plot is given, you have to look at the stem plot or the dot plot, because if there are no strong skewness or there's no outliers, that means we can still say that the sampling distribution of a sample mean is normal. Okay, let's have another example. A city council member wants to estimate how many pounds of trash households in their community produce per week. To determine an estimate for the standard deviation of the weight of trash produced, a small random sample of household was selected and their trash was weighed on a garbage day. This produced an estimated standard deviation of 36 pounds. How many households need to be surveyed to estimate the mean at the 95% confidence level with the margin of error at most 3 pounds? At most means less than or equal to 3 pounds, right? So we're given the margin of error, we're given the confidence level, we are not given, we wanted to know the number of sample. So what's the formula for our margin of error? So margin of error equals T star and Sx over square root of n. So margin of error is 3 equals. Our T star is, okay, let's try to analyze here. In order for us to find the T star, we need a number of sample, correct? Because when we try to find the T star, we need a DF, and DF is number of sample minus 1. So in this case, I'm missing the sample, I'm missing the T star, I'm missing the DF. So how am I gonna solve the problem if I'm missing all of them? So in this case, instead of using T star, we are going to use Z star, because we are trying to estimate the T, that is, we're trying to look for the sample. So in replacement of the T, when that's not available, we are going to use Z. So we are going to take a look at 1.96% in our table. So in our table, 95%, so Z star of 95% is 1.96. So we are going to use 1.96 in here as a replacement for the T star that is not given. So our standard deviation is 36 pounds. 36 pounds over the square root of n. Okay, of course, my first step is dividing both sides by 1.96. So you're going to have 3 over 1.96 equals 36 over the square root of n. And then you're going to multiply both sides by square root of n. And then you are going to square both sides of the equation. Right? I'm hoping that you guys already know how to do that. So my n is equal to 553.19. And of course, we are going to round that up because we're talking about people. Now I'm going to make a note in here. Use Z star when you don't know what T star to use. Okay? There you have it. After solving Part A, the City Council realized that it would be too much work to weigh the garbage of that many households. They gave up on their hopes of estimating the true mean weight of trash produced within 3 pounds and select a random sample of 15 households and weigh the trash for each of these households on garbage day. Here are the results. Calculate and interpret a 95% confidence interval for the mean weight of trash for all households in this community. So it's kind of a lot of work because in this case, we're not given any information. We're not given the mean, we're not given the standard deviation, nothing. Okay, so we have to plug in all of these numbers into our calculator, and hopefully you guys know how to do that already. We're gonna plug it in to add spreadsheet, right? Add list and spreadsheet, and we are going to go to, once you've plug in everything, go to one variable statistics, and I've already done this with you over and over, so hopefully you already know how, but I'm also going to be showing it to you one more time during class. So we are going to have, or before we watch this video, I've already put everything in the calculator, and I got my x bar equals 68.85, and I have my SX as 35.78. Again, I got that from plugging in all the numbers in the calculator and go to one variable statistics. Calculate and interpret a 95% confidence interval, starting with stating the problem. I have my mean is, my parameter is the true mean weight of trash for all households. Okay, for all household in this community. Okay, moving on. And then we have to take note at a 95% confidence level. Okay, plan. We have to name our procedures. So this is one sample T interval, not Z, for mean. Then we have to check our condition. So this is a random sample of 15. Okay, and then 10% condition. We have here 15 is less than 1/10 of all households in the community. Okay, what else do we have for normal? Okay, for normal, it didn't say that the population distribution is normal, so we don't have that advantage of saying, oh, okay, the sampling distribution is normal because the population is normal. Our next choice is to do CLT, the central limit theorem, but it looks like our N is less than 30, right? Our N is only 15. So our N is less than 30. So we can't say that, we can't use CLT in this case. So we are going to do number 3. Sample shows no strong skew or outliers. Because our graph is not given, we actually have to do a dot plot on our own. And that's what is kind of hard in here because we have to make a dot plot. Oh, perfect. I'm going to use this line. There you go. So we're going to make a dot plot for all of these numbers. So I have 20, 30. What's my highest number in there? I have 118. Oh, okay. It's kind of like 20, 30, 40, 50, 60, 70, 80, I know you have to spend time on this one. 100, 110, and then 120. And then we have to make a dot plot, like what we did long time ago. 114.8, so 114, so somewhere in this area. Okay, next is 74. Let me make it smaller. 74.3, somewhere in this area. 80.1, 41.5. So I'm just making this 41.5. 99.1, 31. I know it's kind of 93. 118. Our goal here is to actually just check if there's outliers or if the graph is going to be skewed. 26.5, 33, 88, all approximation, okay? 46, 119, so over here. And then we have 46. What is this one? 41, 46. Oh, another 46 this way. And then we have 19.8. 19.8 over here. Okay. It looks like it's not skewed to the right, it's not skewed to the left. So, and there's no outliers. I don't see any outliers here. In this case, because it is not skewed and no outliers, the sampling distribution of X bar is approximately normal. It's kind of annoying, yeah, when n is not greater than 30 because we actually have to look how the graph would look like, how the dot plot would look like. Hopefully, in the AP exam, the graph is already given, so we don't have to actually graph it on our own. So let us, finally, it passes all the conditions. So let us do our problem. X bar plus and minus T star Sx over square root of n. And then our X bar is 68.85 plus and minus my T star is going to be, let us do our T star. So my DF is 15 minus 1. So my DF is 14 and a 95% confidence. So let's take a look. My DF of 14 at a 95% confidence. Am I correct? 2.145. Yeah, 2.145. So 2.145, and then my standard deviation, which I got from the calculator, over square root of 15. So 68.5 plus and minus. Okay, there you go. Okay. So, why did I erase that? Plus and minus. There you go. I can do it. I wanted to do it separately, but yeah. Plus and minus. I'm going to multiply this whole entire thing all at once in my calculator. I think that's 19.82. Please verify with your own calculator. So I'm going to do 68.85 plus 19.82, and then 68.85 minus 19.82. So that's 0.03 and 88.67. All right, what else are we missing? We have our condition, and I think we are ready for our conclusion. We are 95% confident that the interval from 49.03 to 88.7 pounds, please say that, contains the true mean weight. Because remember, that's what we're trying to estimate. True mean weight for trash for all households in the community. Okay, there you go. That's how we do a confidence interval for sample means. I know it's kind of a lot of process, and I think the most annoying part really is when n is not greater than 30, or when n is not equal to or greater than 30, because we have to do this whole entire making a dot plot thing. Okay, thank you everyone, and I'm hoping that you'll be able to do your homework with no problems. If you do, please let me know if you have any questions, and thank you for listening and for your patience, and I will see you guys in the next video. Bye.